All right, listen up. Forget all that sentimental nonsense about the ocean being our mother. If the atmosphere vanished tomorrow, or if the Earth's crust cracked open like a cheap pressure cooker, the entire Pacific could instantly turn into a boiling vat hot enough to cook your DNA into soup. Your beloved lobster that's smug shark, even the sashimi you never got around to eating. All of it would turn into fully cooked seafood in seconds. This isn't some beach vacation. This is the ultimate planetary hot pot, but deep inside this abyss, hot enough to melt the metabolism of most life. There, as a crew of absolute hardcore survivors, they throw parties in boiling water, they dance in clouds of lethal sulfur. Welcome to forbidden zones of Earth. Today we re-meeting the true heirs of the boiling deep. Number 10. Bathynomus giganteus. The giant isopod at home. When you eat mantis shrimp, you peel off the shell. This thing. It looks like a mantis shrimp on steroids wearing a bulletproof vest, and if it could, it would peel you instead. Just look at it. If the alien from Alien had a distant cousin in the ocean, the giant isopod would be that creepy uncle. That heavy armor covering its body is teeth for decoration. It's built to survive the brutal pressure and punishment of the deep sea. Its massive compound eyes glow in the darkness like scanners, searching for the next corpse that hasn't been fully cooked yet. But the most disgusting part, this creature can go 5 years without eating. But once it finds food, it binges like a maniac at an all. You can eat buffet, stuffing itself until it literally can't move. In the early stages of an ocean overheating disaster, this monster would be one of the first winners. Its shell contains extremely dense chitin cross, basically functioning like a high-temperature diving tank. Its metabolism is absurdly slow, an extreme minimalist metabolism. That sluggish system helps its cells avoid catastrophic overheating even when the surrounding water starts turning into a boiling nightmare. The giant isopod proves one brutal survival rule. If you re-ugly enough and patient enough, you'll probably outlive everyone else. Forget elegance if you re-tough enough. You'll still be around long after the elite species are gone, casually chewing on their remains. Number 9. Kiwa hirsuta, the yeti crab. Some people grow eyelashes for beauty. This guy grows an entire ecosystem on his hands, and then eats it. Meet the yeti crab, the only deep sea outlaw that basically walks around wearing a fur coat. Those ghost white hairs covering its claws aren't tea for warmth. They rebacterial farms. When you see the yeti crab waving its claws around next to boiling sulfur vents, you might think it's performing some bizarre ritual. It's not. It's us fertilizing the bacteria growing on its arms. Imagine someone dancing in a bikini next to a lava flow while licking their own hands for food. That's roughly how strange this scene looks. The yeti crab lives right on the edge of hydrothermal vents. A brutal battlefield where freezing ocean water collides with near-boiling sulfur springs. Its survival strategy is chemosynthetic symbiosis. The enzymes inside its body have evolved extreme heat stability, staying functional even above 60 degrees Celsius. It doesn't rely on oxygen the way most animals do. Instead, it feeds on sulfur, eating bacteria that thrive in this toxic environment. The lesson here, life is a lot like the yeti crab. If the world tries to poison you, learn how to eat the poison. Riftia pachyptula, the giant tube worm. Imagine your lipstick suddenly grew 2 meters long and started breathing in boiling sulfur water. That is basically the giant tube worm, one of the most alien-looking animals on Earth. It has no mouth, no stomach, no anus. Its entire life is spent inside a white tube, with only a bright red plume sticking out of the top. That red colour is its embarrassment. It's extremely concentrated hemoglobin. Visually, it's unsettling, like a piece of raw intestine shoved into a PVC pipe, but its biology is even stranger. Its blood contains a unique protein that can detoxify hydrogen sulfide while simultaneously carrying oxygen. In environments where temperatures can climb close to 80 degrees Celsius, the worm survives using a specialized internal organ called the trophosome. Think of it as a living biochemical factory packed with billions of sulfur-eating bacteria. The worm doesn't eat. It simply hosts the factory. Those bacteria convert toxic chemicals into sugars, feeding the worm in return. It's one of the most elegant biological hacks evolution has ever produced. Give up eating, give up digestion, and suddenly the environment itself becomes your kitchen. The tube worm is extreme minimalism in biological form, thriving in darkness while glowing bright red in the boiling deep. Number 7. Alvinella pompeiana, the Pompeii worm, if you could take a bath in boiling water and still feel chilly. Eudebia Pompeii worm. This creature is the most heat-tolerant complex animal ever discovered. It looks like a hairy worm that just crawled out of an incinerator. That thick, fuzzy layer on its back. Not hair, it's actually a colony of symbiotic bacteria forming something like a living biological insulation suit. The Pompeii worm has a bizarre lifestyle. Its head stays in relatively cooler water, while its tail sits directly inside hydrothermal vents hotter than 100 degrees Celsius. It's basically living between ice and fire. Imagine someone sticking their feet into a steel furnace while calmly eating ice cream. That's the Pompeii worm's daily routine. Its collagen and proteins are radically different from those in normal animals. Most proteins start breaking down around 50 degrees Celsius. But Pompeii worm proteins are reinforced with dense disulfide bonds and hydrophobic cores, which keep their molecular structure stable even in near boiling conditions. In materials science terms, this is basically nature inventing high-temperature biomaterials. Real survivors keep their backs to the fire. The Pompeii worm teaches a brutal lesson. If you want to survive in a boiling world, you better grow yourself a very thick bacterial armor. Number 6. Chrysomelon squamiferum. The scaly foot snail, still saving up for that shiny new cyber. Truck, take a look at this guy. He didn't buy armor. He grew it. The scaly foot snail is the only known animal on Earth capable of building metal armor into its own body. At first glance, it looks less like a snail and more like a piece of medieval knight armor lost on the seafloor. Its foot isn't soft flesh like a normal snail. Instead, it's covered in overlapping iron sulfide scales like a biological chainmail suit. In the boiling, acidic water around hydrothermal vents, this creature crawls around like a tank driving along the edge of a volcano, and the intimidation factor is real. There's something deeply unsettling about it, because it does look organic. It looks mechanical. Its armor is built in 3 layers, an inner calcified shell, a middle organic shock, absorbing layer, and an outer coating made from nanocrystals of magnetite and pyrite. In other words, it literally turns toxic minerals from the ocean into body armor. When temperatures spike high enough to melt normal proteins, that iron shell becomes its ultimate defense there. It's a harsh survival rule hidden here. If the world keeps firing poison bullets at you, melt those bullets down and forge your own armor. The scaly foot snail understands something most organisms never learn. Your heart can stay soft, but your shell, that better be steel. Number 5. Actinostolidae thermophilic sea anemones buying flowers for Valentine's Day. Waste of money. Give someone one of these flowers and they probably turn into a puddle of blood, because these are flowers that bloom at the gates of hell. Some deep sea anemones from the Actinostolidae family anchor themselves directly to hydrothermal black smokers, volcanic chimneys blasting out clouds of toxic chemicals. Around them is a chemical soup strong enough to poison an entire city. Their pale tentacles drift through the boiling black water like ghostly strands of intestine. Visually, it's unsettling. It looks like a crowd of drowned spirits reaching up from the bottom of a pot, under deep sea pressure. Water can remain liquid even at 150 degrees Celsius. These anemones survive because their cell membranes contain unusual branched lipids, preventing the membrane from melting like butter under extreme heat. Their tentacles serve 2 purposes: hunting prey and acting like biological radiators, bleeding off excess heat. Some studies even suggest they can harvest bioelectric energy from the extreme temperature gradients around the vents. The most dangerous places often grow the most beautiful traps. These anemones bloom in toxic ash fields, quiet proof that if you reach strong enough, even hell can become a garden. Number 4. Alicella gigante, the giant amphipod. The shrimp you buy at the grocery store are the size of your finger. Down here, some amphipods grow larger than your house cat. If you ever met one in a boiling deep-sea apocalypse, you dare be the shrimp. The giant amphipod looks like a white flea enlarged 1,000 times. Through its translucent shell, you can see its organs slowly writhing inside. That alone triggers a kind of primal discomfort because creatures simply aren't supposed to get this big down here. It moves with explosive bursts of speed, bouncing through the water so quickly that cameras struggle to track it. It's like watching a nightmare repeatedly ricochet through a sealed metal room, but its real superpower is chemistry. The giant amphipod's body contains extremely high concentrations of trimethylamine N-oxide, TMAO. This compound stabilizes proteins under enormous pressure and also acts like a thermal buffer, protecting cellular machinery during sudden bursts of heat from hydrothermal vents. So when the ocean starts boiling and entire ecosystems collapse, this creature becomes the ultimate scavenger. It sweeps through the chaos, devouring the endless supply of newly cooked victims. There's a dark truth about apocalypses. Sometimes survival isn't about being the strongest. Sometimes it's about being the one with the biggest appetite. When the world turns into a boiling graveyard, the giant amphipod becomes the monster that eats the graveyard. Number 3. Thermococcus gametolerans. Throw this thing into Chernobyl or toss it into a microwave. It probably wouldn't die if anything. It might complain the heat isn't high enough. You can see it with the naked eye. But under a microscope, it looks like a tiny spiked sphere spinning in place like a microscopic buzzsaw. Heat. Doesn't he care pressure? Doesn't he care radiation? Still doesn't he care? This microbe lives right next to radioactive minerals in hydrothermal vent systems. And compared to it, humans, creatures that get skin cancer from too much sunlight, look embarrassingly fragile. Among known organisms, it has one of the most powerful radiation-resistant systems ever discovered. Its secret weapon is a near supernatural DNA repair mechanism. Radiation shatters its DNA into fragments. No problem. Within minutes, it can stitch the pieces back together like a perfectly solved puzzle. The repair process is so fast that, in a sense, time itself almost stops mattering. In a boiling radioactive deep-sea wasteland, this organism wouldn't just survive. It would sit there like a quiet observer, watching the apocalypse unfold. There is a brutal rule of survival here. If you can heal faster than the damage happens, you're basically impossible to kill. This organism isn't just surviving, it's challenging the rules of biology itself. Number 2. Geogemma barossi strain 121. Alright? Crank your pressure cooker to maximum for most life. 100 degrees Celsius means instant death. For strain 121, that's just the warm, up for a hot bath. Scientists once placed this organism inside a laboratory autoclave, heating it to 121 degrees Celsius. A temperature universally considered the absolute sterilization point in medicine. Hospitals rely on that temperature to kill everything. Everything except this. Not only did it survive the autoclave, it reproduced inside it. The experiment designed to kill it turned into a maternity ward. In other words, humanity's most powerful sterilization method accidentally became this microbe's romantic getaway. Under a microscope, it appears as a tiny single-celled sphere with a long whip-like tail. Its metabolism runs on something called iron reduction. It doesn't breathe oxygen. Instead, it literally breathes iron oxides. Its cell membranes and proteins contain an extremely rare structural feature known as ion pair stabilization. Think of it like molecular superglue, locking proteins together so tightly that heat struggles to tear them apart. In fact, when temperatures drop below 85 degrees Celsius, the organism actually slows down. to strain 121 that S practically cold weather. This microbe exists in a region biology textbooks once labelled impossible. It's a living contradiction to decades of medical assumptions. And it teaches a brutal evolutionary lesson. If you become strong enough, your enemy, ultimate weapon, can become your comfort zone. Number 1. Pyrolobus, fumari, and finally the organism that would treat a boiling ocean like paradise. When the atmosphere disappears and the oceans begin to boil, when volcanic vents push temperatures to 113 degrees Celsius and beyond, when nearly every carbon-based life form on Earth screams and dissolves, this thing would still be there, sitting calmly at the very top of a black smoke event. This organism is one of the most heat-tolerant life forms ever discovered. In many ways, it represents something ancient, a biological echo of the very origins of life on Earth. Under a microscope, it looks almost absurdly simple, a small flattened disc with no unnecessary structures, no fancy organs, no elaborate systems, just the purest form of survival machinery. It lives directly inside the hottest part of hydrothermal vents, the fiery plume where superheated water erupts from the crust. Its metabolism completely abandons sunlight. Instead, it uses hydrogen and carbon dioxide to power a chemical form of life known as chemosynthesis. Its DNA is packed into an extremely tight supercoiled structure, protecting the genetic code from unraveling in near boiling water. It doesn't need sunlight. It doesn't need an atmosphere. It barely even needs what we normally call an ecosystem. In a strange way, this organism represents both the beginning and the possible end of life on Earth. Because when all the forests burn, when the oceans boil, when complex life collapses, the simplest rules of biology remain, and creatures like this will still be there, quiet, unbothered, waiting for the planet to start over again.